Hello and welcome. We're going to go over some concepts that are helpful to have reviewed before starting your pre-algebra class. So starting with some decimals here, we've got adding and subtracting. So the key thing to remember when you're adding or subtracting decimals is that you need to line up the decimal place. So on number 1, I'm going to use the side here to show my work. On number 1, I have 7.2. plus 13.7, and so I want to write this in such a way that I can see that my decimals line up. And the neater you are, the better, because if you're really messy, it can be hard to keep track of what you're supposed to be putting in the same column. But if you write neatly, then it should be easy to see that the 2 and the 7 are in the same column. So I'm going to add those and get 9. I drop the decimal down. 7 plus 3 is 10, so I write down 0, and then I carry a 1. That 1 plus this one is 20.9 for my answer. So 20.9. Feel free, if you think that that was a big enough review for you to get started and try the next one on your own, feel free to pause the video and then start it back up once you've finished. So number 1 is done. Number 2, we want to do 2.41 plus 34.6. All right, so these don't have the same number of decimal places, and so it's just important to line up the decimals. And then we can put a 0 here as a placeholder if that helps you keep track, because the 1, which is in the hundredths place of this decimal, there's not anything to add with on this one because there's not a hundredths place. There's not 2 decimal places. So we want to do 1 plus 0, which is 1. Now we're going to do 4 plus 6, which is 0, and we're going to carry our 1 by placing it up on top. We're going to put our decimal down so we don't forget about it. Or if you want to put the decimal at the end, that's fine. Just make sure that you remember for adding and subtracting, the decimal comes straight down. It's multiplication that is a little different and a little trickier. So we want to do 1 plus 2 plus 4. 1 plus 2 is 3. 3 plus 4 is 7. And then there's nothing to add with the 3, so our answer is 37.01. You might be careful with if you're like numbering these like this, maybe it would be better to put a parentheses. Just make sure you don't think that the problem number is a part of your problem, that it wasn't 22.41 or some weird 2.241 decimal place, I don't know. Number 3. Now notice here we're subtracting. So we've got 10.5 minus 7.3. Now when we're subtracting, we do the top number minus the bottom number, but if there is not enough for us to be able to actually subtract them, we have to borrow from the next spot over. So 5 minus 3 is 2. We do drop down the decimal place just like with addition. 0 minus 7 doesn't work. So we're essentially borrowing this 1. You can either do that by marking it out and showing borrow, or I would argue in this case that it's really not that hard since it's on the end to just say, oh, 10 minus 7 is 3. Whichever way you'd like to do that is fine. The answer to this is 3.2. And number 4, I'm going to put up higher. And apparently with a bolder marker, 27.1 minus 18.6. So 27.1 minus 18.6. So we need to do 1 minus 6, which we can't do that. So we're going to have to borrow and change this to a 6 and make this have an 11 now. 11 minus 6 is 5. Then we drop down our decimal. 6 minus 8, can't do that, so I'm going to have to borrow again. 16 minus 8 is 8, and then 1 minus 1 is 0, so my answer here is 8.5. So the biggest thing I would say on remembering adding and subtracting decimals is to keep track of where your decimal place is, that it drops down, and also to make sure that you are either carrying your ones if you're adding or borrowing correctly if you're subtracting. So now let's multiply and divide. Multiplication and division have different rules than addition and subtraction. That's going to be kind of a constant theme from here on out, since you're about to do pre-algebra and then algebra. That's just going to continue being the case. It's also the case for fractions. We're going to do 3.2 times 1.4. If one of these was a longer number, had more numbers to it, we would want to put that on top just to make our work easier. But these both have 2 numbers, so it didn't matter which one was on top. We start with the 4 and we multiply the 3 and the 2 by 4. So 4 times 2 is 8 and 4 times 3 is 12. And we can write 2 and then carry the 1, but we're just going to end up putting it down here. Then whenever we do the tens place, we have to start by putting a 0 here and then do 1 times the 2 and times the 3. So 1 times 2 is 2 and 1 times 3 is 3. And then we add these together. So 8 plus 0 is 8, 2 plus 2 is 4, 1 plus 3 is 4. And especially here, if you aren't being very neat, you can get jumbled up with your columns. So you want to be very careful with how you write your work. Whenever you're doing multiplication, you count how many decimals you had at the start, and that's how many decimals you need at the end. So 1 decimal on the first one, a second decimal on the second one, means that there should be 2 decimal places here for an answer of 4.48. So that's our answer. Number 6, we have 0.5 times 27. So I'm going to put the 27 first, because even though 0.5 technically has 2 numbers, the 0 part of that is not going to really matter. So it's not something you have to do, but I feel like it makes our work nicer if we understand what's going on here and do it a certain way. We're going to do 5 times 7, which is 35. So write down your 5 and carry the 3. 5 times 2 is 10, and then we need to add the 3. So that makes 13. And if we do 0 times these numbers, it just gives us 0 again. So we don't actually need to do that. We can just, it's almost like we can just ignore that that was there. And this is really just a 2-digit number times a 1-digit number. And then count the number of decimals you have. There's only 1 decimal place. So this is 13.5. And it occurs to me, you may have been able to figure that out faster a different way by thinking about how 0.5 is a half and thinking about what half of 27 is. I'm going to need some room here for 7 and 8, I believe. So I guess I'll start it here and see what happens. We are dividing 27.88 by 8.2. So the 8.2 needs to be on the outside, and the 27.88 is going to be on the inside. It's not going to be enough room. All right, let's see here. Now, whenever we are doing this, we need to start off by getting rid of the decimal that's on the outside. So because it's 8.2, what I want it to be is 82. So that requires me moving the decimal over 1 place. So we have to do the same thing here and move it over a place here. I actually, because of the way I like to write things, I would actually personally prefer to do it like over here before I wrote it down. I don't like how that looks personally with the little extra writing. So if it were me, I would just say I'm gonna change it before I write it down. But that's up to you. All right, now we're ready to do our division. So we're gonna say, how many times does 82 go into 2? No time. So we're not gonna write anything above the 2. How many times does 82 go into 27? It doesn't. So we're not gonna write anything above the 2 or the 7. How many times does 82 go into 278? Well, I may not know for sure, but if I think about how many times 8 goes into 27, that would go 3 with some left over. So I'm gonna try 3. The thing that's frustrating about long division with 2-digit numbers is having to kind of guess and check to see what works. 82 times 3 is 246, and I'm pretty confident that 4 would be too big, so I'm going to put a 3 up here. The decimal does travel up, by the way. It moved because we moved it at the beginning, but it doesn't move anywhere again if we're keeping track up here. So we said 82 times 3 is 246. So we have to subtract the 246. And so 2 minus, well, that's not how we subtract. 8 minus 6 is 2. 7 minus 4 is 3. And 2 minus 2 is 0. So now I've got 32. Now I take the 8 and drop it down. And then I start this over. I say, how many times does 82 go into 328? And I would look at it and say, how many times does 8 go into 32? That's 4. So let's give that a try and see what happens when we times by 4. We get 328. So we put 4 here, minus 328, and we get 0, which is good, because if we don't get 0 there, and since this is already a decimal, we'd have to keep going and add more zeros and hope that it would be something that would end pretty quickly. So 3.4 is my answer. Let's try number 8. So 11.9 divided by 1.7. You take what you're dividing by, so this 1.7, we want to turn it into 17, and then that means we need to also change this one as well. So we're going to do 119 divided by 17. So 17 does not go into 1, 17 doesn't go into 11, 17 goes into 119, although I don't really know how many times. We would try thinking about rounding this up and thinking about how many times does 20 go into 119. And that would suggest to me that 6 is a good place to start. So 7 times 6 is 42. 6 times 1 is 6, plus 4 is 100. So 17 times 6 is 102, but you know what? I think we can do better. I think 17 times 7 is 119. So our answer is just 7, which I've kind of written where I was writing my answers before, is equals just 7. So we move the decimal at the beginning to make it even, or not to make it even. We have to get rid of the decimal that is in our divisor, and that got rid of the decimal that was in the dividend, and so that's how we end up with just a regular old 7. On 9 through 12, we've got operations with positives and negatives with integers, and so it's important to understand the rules. There's only 4 questions here, but this is really asking us, do we know how to work with these things? So for instance, on 9, we have negative 19 plus 12, so we have to think to ourselves, if I have a negative and a positive, I subtract my numbers but keep the sign of the larger number. So I'm going to do 19 minus 20, or 19 minus 12 and get 7, but it's negative because the bigger number was negative, the 19 was negative. And you can think of this a bunch of different ways, like you can imagine a number line where you start at negative 19, and we're moving to the right 12 because we're adding 12, and so we'd stop when we get to negative 7. You can think about it like you have 2 teams, a positive team and a negative team, and which team would have more is the team that has a bigger number, and how many more they have would be what we're left with. Like think about a teammate on each side canceling out, and that would work. So those are kind of some of the things that we think about when we're trying to add positives and negatives. Number 10 says 8 minus negative 20, which if you do 8 minus a negative, you're really being asked to add. When you see 2 negatives next to each other like that with nothing in between other than a parentheses like this, we can change them both so that they're plus. 2 negatives make a positive in math, in English, but not in real life. So we actually are being asked here to do 8 plus 20, which is 28. The rules for multiplying and dividing is that when you multiply 2 numbers together, if there is 1 negative, it's going to make it negative overall. But if you have 2 negatives, the negatives cancel each other out. And that would actually continue on, that any odd number of negatives ends up being negative, any even number of negatives ends up being positive. So 6 times negative 7 is 42, but it's negative because one of them is negative. The similar rule happens for division. If both of these are negative, those negatives actually go away. They cancel each other out, and that's multiplication and division that happens, that because they're both negative here, they cancel. 5 goes into 75, you might decide to come over here and do some division, which maybe you can do this pretty quickly and say 5 into 7 is once. And you could probably even keep track of it in your head instead of having to subtract. We get 15, and it is positive because of the negatives canceling. All right, now we have some distributive property, and we've got some adding like terms, and then we'll end with some fractions, I believe. So the distributive property is the property that says if we're multiplying something that inside has two things and on the outside we have one thing, then we just need to make sure to multiply everything on the inside by this thing that's on the outside. So you'll typically see people draw these arrows to show that we want to do 9 times x, and then we also want to do 9 times -4. Well, 9 times x, we just write that together as 9x. 9 times -4, we multiply that out and get a -36 because we only have one negative. So our answer to this is 9x minus 36. So that's the idea with the distributive property. Multiply everything inside by what's on the outside. So let's try it here. This is another good place to pause the video to see if you can do the rest on your own in this section. So 8 times z is 8z. I like to put little lines through my z's so they look less like 2's. 8 times -7 is -56. That'd be our answer for this one. Now 15 getting tricky with us. We've got a negative number on the outside now. So -6 times -m. A negative times a negative is a positive, and 6 times m is 6m. And then -6 times positive 12 would be negative, and that would be 72. If you, as you're going along here, are having trouble remembering things like 6 times 12, it would not be a bad idea to try to review your multiplication tables a little bit, because those are the kind of things you're going to be doing a lot in pre-algebra and algebra 1, is just having to do mental math like that. So think about it. 16, 17, and 18 say simplify the expression. We have c plus 4 minus c. Well, what's happening here is c represents something that is the same in both of these cases. So if we have one c and we subtract another c, then we would have 0 c's. Think about it like it's actually something that starts with a c, like carrots. You have 1 carrot, you subtract 1 carrot, now you have 0 carrots. Or maybe you'd prefer to think about cash. You have 1 cash, and then you subtract 1 cash, you have 0 cash. So these actually make each other go away, and you're left with this 4, and there's nothing else in the problem, so our answer has to be just 4. So this is on 16, 17, 18, a test of like terms. We call things like terms when they're the same letter and when that letter has the same exponent. So 9b minus 12b, we would say, okay, I can put those together. I can't put them together with the plus 3 though, because the plus 3 is something else entirely. Maybe 9b and -12b are talking about bees, you know, like the insect, and this 3 is talking about apples or something. Well, we can't put those together as a b or without a b because they're not the same thing. So 9b minus 12b, we need to think, what's 9 minus 12, which we would, since this is subtraction, we subtract the numbers and find out how far apart they are. And then our answer is negative because the 12 here is what is bigger. So that's going to give you -3b. And then this plus 3 doesn't have any normal numbers to change it. Like if we had another plus 5 or something here, we could change it. We don't. So it's just -3b plus 3. Number 18, we have some distributive property here. Even though it didn't say it specifically, that's part of simplifying, is getting rid of parentheses. And we have to do that first before we do anything else, because if you remember PEMDAS, which talks about order of operations, parentheses are the first thing you need to do before multiplication. So we want to get rid of them by distributing. So that's 4a plus 8. And then the plus a is still there. And now that our parentheses are gone, which I guess you would think of that like multiplication too, that either way, that came first. Now we're ready to add like terms. The 4a and the a are both a's. So we can say, well, 4a plus 1a equals 5a. And then the 8 just stays 8. So that would be our answer. Now we've got fractions. So the way we deal with fractions, adding and subtracting, is we need common denominators. The way we deal with multiplication and division is different. And that's one of the things that can make us frustrated about fractions, just like it makes us frustrated with decimals. The fact that they're different is annoying because then we have to think harder about what we're doing. So for adding and subtracting, we need a common denominator. 19, we already have a common denominator. If I have 4/7 and I add 2/7 to it, what I end up with is 4 plus 2, which is 6/7. And if you think about the way I said that, it's also kind of like having like terms. You have 4 of something and you're adding 2 of the same sort of thing. So that gives you 6 of that thing. That's why I'm not adding and making this 14 on the bottom. And the same is true with subtracting. If you have 12 25ths, where 25ths is a thing, and you subtract from that 4 25ths, you should end up with 12 minus 4, which is 8 25ths. And so the 25 still stays the same because that was our common denominator. Now what do we do if we don't have a common denominator? We get one, and we're allowed to get one using multiplication. We look at these denominators and we say, can I turn one of these into the other using multiplication? Or division technically would work. If we could divide the second fraction by 2 on top and bottom, we could get a common denominator that way. But that won't work very well because 5 doesn't divide by 2 evenly. So instead we want to look over here and say, well, I can make 12 be 24 if I just multiply it by 2. So we have to do that to the top as well. Because if we do it to the top and the bottom, we're getting an equivalent fraction. If we only did it to the bottom and not the top, we would just be doing incorrect math. We would have changed this to a completely different fraction. Whereas if I do it to the top and bottom, 14 over 24 is actually the same fraction as 7 over 12 because you can reduce it and get back to 7 over 12. Now that they're both over 24, we can do 14 minus 5 and get 9 over 24. Now sometimes our common denominators are more difficult. 21 and 14 are not super easy to figure out what to make them both turn into. So let's use something else to help us. Let's use factors. 21 is 3 times 7 and 14 is 2 times 7. So what that means is that if I times the first fraction by 2, I will get the same thing as if I times the second one by 3. Because look, now I have all the same numbers in both of these places. What number is that? If I times the 21 by 2, I get 42. Now, I don't know about you, but I did not know off the top of my head that 14 went to 42. I would have had to do a little bit of work to figure that out. So this is a cool strategy for that. Since I times this by 2 to get it to be 42, I have to times the top by 2. And since I times the 14 by 3, I need to times the 9 by 3. So we need to say 16 plus 27. Ooh, I just realized that I made a mistake on number 21. So I'll go back to that in a second. 16 plus 27 is 43 over 42, which 42 goes into 43 one time with 1 left over. So our answer would be 1 and 142. 9 over 24 reduces, so we should definitely not have circled that as our answer because we should say if both of these divide by 3, this should really be 3 over 8. That is absolutely something that you need to do. You should always reduce your fractions every single time, whether it tells you to or not. It's always better to have a simpler fraction with smaller numbers than leaving it as bigger numbers. When we multiply or divide, well, I guess they're similar. There's a key step that's different between them. When we multiply, though, what we're going to end up doing is the top times the top and the bottom times the bottom, unless we first can cancel something out. So just like with the 9/24, how I canceled out a 3, if there's something that 18 and 19 have in common that I can cancel, I should, or 38 and 27, I should. Or if 18 and 27 have something that cancels, I should do that. So thinking about 18 and 27, both of those are divisible by 9. They're also divisible by 3, but if I pick the biggest number, 9, if I divide 18 by 9, it gives me 2, and if I divide 27 by 9, it gives me 3. So that reduces that and makes it easier. If I also realize that 38 and 19 are both divisible by 19, I can make this even easier to multiply. That would make this turn into 2, and this 19 divided by 19 would be 1. Now when I multiply on top, I'm doing 2 times 2, which is 4, and 1 times 3, which is 3, which when you're doing a mixed number, you say 3 goes into 4 one time, and then there'd still be 1 left over for my fractions. So this would be 1 1/3. On 24, the thing that's different when you're dividing is that you have to rewrite it with the second fraction flipped, and flipping the second fraction lets us turn this into a multiplication problem. And so we can do the same thing we did a moment ago where we look for things that cancel. So the 6 and the 36 can cancel because we can divide them both by 6. The 77 and the 7 can cancel because we can divide them both by 7. So 1 times 11 is 11, and 1 times 6 is 6. 6 goes into 11 one time with 5 left over. So that would be our answer. If anything in here was super tricky for you, you should try with your parents or with a friend or something, someone who knows this a little bit better than you. You should have them come up with some problems for you to practice going over, or you can use other resources on the internet with possibly someone else's help to get more practice problems and also to get more in-depth videos of these concepts. Thanks so much for watching.